All right, so we're going to talk today about Nginx, and this talk is mainly aimed at people who are .NET developers, particularly moving to that .NET Core, running things on the Unix platform, who need to understand what Nginx is and what it can do for them. If you're not a .NET developer but you want to know about Nginx, we will probably cover enough of what Nginx does without you having to know anything much about what .NET actually does to feel comfortable you could get something out of it. And it's designed to really be, if you like, an introductory talk. We will cover off some of the basic scenarios that you need, reverse proxy, load balancing. There's a lot of depth to something like Nginx. We could spend 3 or 4 hours talking about all the options, but hopefully this will get you started and get you enough to basically be able to deploy into production environments, and then you can start tweaking things to your heart's content. Who am I? Most of this slide is really quite unimportant. The only bit you really care about, I mentioned at the bottom, is this kind of no smart guys rule. Those of you, by the way, the backish, there are monitors there. Hopefully you can see stuff, but I will read bits on the bottom of the slide. It just says no smart guys, only the guys in this room. And there is my challenge to you guys is I'm not smarter than you. I just happen to be confident enough to come and stand here and speak, and I did that because I overcame my lack of confidence by just speaking, starting out with things like lightning talks and user groups, etc. And all of you could be up here doing what I do, and I encourage you to have a go and participate. And it's really good for, I think, you as a developer, because it helps you to structure and organize your thoughts a lot about what about your practice. And I think the other thing to bear in mind, from people say, I haven't got anything to talk about. That's because you talk to your peers and they know what you do, but many people don't know what you know. And any of you who are not, more experienced developers, you have wisdom and understanding to pass on to junior developers. We need people out there still doing talks about the basics of TDD and those kind of things for new guys to learn, right? So please do speak. That's where I work. You don't really care, apart from the fact that I'm not a consultant. I have nothing to sell you, right? And this is just a plug for Brighter. How many of you are .NET developers? Right, so how many of you have heard of Brighter? Okay, fine. So this is a CQRS framework that I work on. It also does basically task queues, messaging basically between your web app and a worker process, so that you can offload work to a worker process, and you can use it for communication between microservices via basically messaging. And we built it at Huddle, and we've open sourced it, and people outside Huddle as well work on it with us. So it's an alternative to things like N-Service Bus and mass transit. So please check us out. You can find us by just searching for Brighter Command on Twitter, or go searching for Brighter Command on GitHub, and you'll find us. Okay. What's today's agenda? First of all, what I'm going to do is do a little demo, right? And we will start with a little demo of a little web app, and I will show you it running without any kind of proxy in it, and then I will show you running with a proxy. And expect to be a bit confused, because I'll show you basically Nginx, etc. running without explaining everything in detail, but I want to give you a feel for what we're actually building towards understanding. And then we'll start digging a little bit into some detail. We'll talk about Kestrel, what it is and what it isn't. Then we'll talk about Nginx itself, what it does for you, how it works, and then we'll talk about some key scenarios, reverse proxy and load balancing. And we'll come back to doing demos when we get to reverse proxy and load balancing, show you a whole range of different scenarios. Okay. Then we'll have a kind of Q&A at the end, and I'll probably hopefully have time to mention a few things we didn't cover that Nginx will do for you. I don't know, given the amount of time it will take to run through all of that, we'll have much time for questions in the session, but please feel free to catch me during the day and afterwards. Okay. So let's do this. Let's have a quick look. Right, so this is a ASP.NET Core application, and it's basically web API, so we're going to basically create an API that we can serve. This is the world's most overcomplicated Hello World application. And what we can do, this is basically file which shows what we can do. We can say, I can post a given greeting to this endpoint, say basically with my message, Hello World, and then effectively I can go and get my list of greetings back. Okay, and I will show you a little bit of how it works, but we're not really that interested in that. So you can see there I've got an HTTP post, and what we're actually using is, we just mentioned, can everyone see, by the way? Anyone need it bigger? Good. Okay. Just shout if basically things are not visible or not audible, shout, and I will fix it. Okay. So we're actually using Brighter and Darker here at the framework. So I can explain to you very quickly what's happening. So the command processor just says we are sending a command to do something. Here we're going to add a greeting. And the query processor says return us some results. And what happens is they map over to handlers. And what it lets us do is build a pipeline such that we can insert things in between for things like retry semantics, circuit breakers, logging, etc. We document all of that elsewhere, but let me just go to ports and handlers. And down here, for example, you can find add greeting command. We just basically spin up a entity framework core DB context, and we just basically add everything into the database. Obviously, we're all async whole way through. Obviously, nowadays, please try and be async if you can. And this, for example, is a greetings by ID query. And we're just literally going to that context and greeting. You can see some attributes there, query retriable, and you can see some here. That's essentially, those attributes represent pieces of the pipeline we're inserting to do some work beforehand. That's not the subject of this talk, but if you want to go and have a look at what we're doing on Brighter, that'd be interesting. Okay, so let me just switch this in GitHub to a standalone version. Right, so this version is standalone. All right, so the other thing we've got here is a Docker compose file. Who's familiar with Docker? Most of you, okay. For those of you that aren't, I'm probably going to not do a big detailed introduction to Docker as part of this. Hopefully you'll be able to follow anyway. So what we're saying is we're going to build two services here, basically. The web service, which is going to be our actual web application that we want to launch, and essentially a database. We're using MySQL just because it's a lighter footprint in Docker than SQL Server for Linux, which requires a lot of memory on my box. And we're just spinning up both those applications. Okay? And then this test HTTP file will let us fire some requests against that application. So we're going to go over here. I don't know why there's a keyboard setup assistant. It's a very disturbing thing to see in the middle of a demo, but let's hope there's nothing there that just runs. Let me just get this a bit bigger. Okay, and then we're going to just do Docker compose up to bring up basically all those servers. Actually, probably what I should just check I need to do first is I'll just check I need to build it first. I sometimes do, and I might as well do that first rather than get an error. So what we're doing is building and publishing to an out directory, so effectively we're not using the whole of the SDK. And then effectively when we build our Docker container, we will take the build artifacts from that out directory and load them into the container that runs the web app. So it's like watching paint dry, and then we're going to bring those servers up. And you'll see we basically pull down the images. We've actually got them all locally, and then we're just spinning up the various containers. And you should see a final message at the end after MySQL's finished doing its thing. We will see a final message that says basically we're listening on port 5000, which is kind of the default for an ASP.NET. Some of you can't see that maybe at the back, but it's just saying I'm listening on port 5000. Don't worry about that. Okay, and then I can send a request. Whoops, a daisy. I don't know why that's not running on standalone at the minute. That used to run all the time. Let me just have a quick check if I can fix that. If not, we'll move on to the next bit of the demo. Oh, I'm running on 5000, right? Okay, sorry. I don't know why this file is. Hang on, let me just shut that file in case it's from. Okay, right. So the only trouble with switching between GitHub files and changing the addresses on stuff is if you forget to close it, you're pointing at completely the wrong location. Right, so this is the one we want to point to initially. There's a few heart-stopping moments while basically it figures out how to do that. So I've got nothing in there currently. send a message, I've got a greeting in there, and I can pull back that greeting, I can send another message, and I'm just pulling back a whole load of greetings, all right? So I've built this fabulous Hello World greetings application. All I need now is an initial coin offering, and I will effectively be rich, okay? But maybe I've read some documentation, and it says to me, you know, you don't really, Kestrel's an HTTP server, but you don't really want to use Kestrel as effectively the edge server for your application, because although will actually do HTTP processing, it lacks many of the features you and I might want. For example, compression. It lacks essentially the ability to do proxy cache, URL rewriting. It does do SSL, but not really in a sense that you would want to rely on for your actual application. So I want something to stick in front of that, and that's essentially what Nginx will do for me. Nginx will sit in front of that and let me deploy my application to live. So I'm going to choose this one because it's fairly clear and easy. So what you'll notice in this, we'll shut these down. You don't really care about the code anymore right now. Right. What I've got here is an Nginx folder, and in my Nginx folder now I've basically got a Docker file for building Nginx, which is fairly straightforward. The main thing to note there is what I do is I copy over a configuration file, and the configuration file in Nginx is the heart of what I'm essentially trying to do here, which is to provide basically a layer between an edge web server. So you can see I'm doing a few things in here. Don't worry about them too much. I'm doing some things to modify TCP. I'm doing some stuff to provide some compression, and I'm turning off server tokens for security. I'm adding a few security headers. But the key thing basically to have a quick look at is what I'm doing is exposing effectively a server, and that server is listening on port 80. And the location it's listening at effectively is root. So it's getting all my requests coming into localhost on port 80. And then it's saying, when you get those, do a proxy path. So it's saying, pass that across to basically HTTP app servers. What's HTTP app servers? Well, you can see I defined something called Upstream. Upstream is actually used for load balancing, but we'll come back to that a little bit later. But in there, I'm saying, find basically on port 5000, something running with basically a DNS entry matches web, and direct the traffic to them. Okay, that's a lot to take in at once. We will explain all this more slowly as we go through. I wanted to show you running end to end, but we're going to essentially be able to talk to this thing now effectively on a different port. So in my Docker compose file, you'll see what my reverse proxy doing is saying, well, I listen to basically externally on port 8080 to the Docker host. Internally, that looks like port 80, but I'm listening on port 8080. You can see the web no longer has a ports. It's no longer possible to access that web container from outside the Docker host. We do have an expose, which says the container is exposing 5000 to other applications in the network that Compose is creating. But you couldn't get to this directly. You have to now go through my proxy. Okay. I should really have shut this down first. Let's see about that. Okay. So I'm going to bring up this one. Now it's running. Well, what we're going to do is get the test HTTP file open again. And you'll see now rather than 5000, we're actually hitting it on 8080. And we'll run that and get back. And you'll notice now we've got a few extra headers. It tells us that the server is Nginx. We around, I better shoot myself with a laser. So servers on Nginx, and you can see we've got some of these security headers we talk about. So we're saying same origin for frames, don't sniff content type, effectively, etc. Do some XSS protection. Encode this basically as gzip, right? So we're compressing the content on the wire, effectively in some other settings. So we've added a few bits of robustness to the HTTP server we got out of the box with Kestrel. Okay, and we're just proxying from the call to Nginx over to our application server. Okay. Oh dear. What we'll do now is we will go back through that in a little bit more slowly so that you guys can figure out what the hell we're actually talking about in most of that. Okay. So I just wanted to give you a feel for what the whole thing looks like, and now I'll explain all those concepts bit by bit, and we'll put up on the ways to understand it. So by the end, everything I showed you there should be really clear to you. Okay. So let's talk about Kestrel. Kestrel is a HTTP server that comes basically with ASP.NET Core, and essentially what Kestrel will do for you is listen on a port, parse basically the content coming in that TCP port into a HTTP request, and then essentially spin up a handler and manage code and direct effectively that particular request to your handler, and then send the response back out, right? But it doesn't do all the other things that we may come to think about being needed effectively for a web application. And certainly if we're used to using something like IIS, it doesn't do any of the things that we've come to suspect out of IIS, like URL rewriting, caching, etc. Okay. So Kestrel is built around libuv. So libuv is essentially the library that also drives things like Node.js. And what happens with libuv is we say, what I want to do is listen on a port for, say, a TCP IP connection. And when I get one, what I then want to do essentially is execute some code. And I will execute that code until such a point effectively as that piece of code decides it's going to do effectively some kind of I/O, which point I will then say, right, well, I'm waiting for you again, and I will execute with that original thread some other request basically that's now waiting. Okay. So what happens is you can use one thread to successively serve requests that are coming in, and every time essentially that thread pauses to do some kind of I/O or other asynchronous work, use that thread to service the next request in sequence. And that enables you with one thread to serve a large number of requests. And that is the underlying technology behind, say, Node.js, and why when it came out, it was a kind of a bit of a revolution in server performance. Okay. It's cross-platform. So one of the big things about ASP.NET Core is essentially we can run on multiple platforms, and in particular you're interested in a lot of cases in running on a Linux, and effectively either a Linux server or effectively a container within Docker. And IIS is not cross-platform, so you're not going to be able to use IIS in those scenarios. And essentially it's the production server for ASP.NET Core. Okay. So Kestrel basically uses libuv, but it actually uses multiple libuv loops. So what it does is says effectively, well, the trouble with libuv is I'm only using one thread. I may have multiple threads. So what something like Node.js forces you to do is run multiple Node.js instances on the box to use the box's resources. What Kestrel says is, well, I'll just basically use multiple threads, and each one of those threads will effectively run a libuv loop for you. Okay. The only thing it's doing on the libuv loop is I/O, right? So essentially, it's the requests coming in and any I/O you're doing. Otherwise, you're in managed code. So it's basically calling into managed code, starts to manage code thread to execute your code. Right? And it's optimized for a low number of syscalls. And it's fast, right? I don't know if any of you've seen these kind of, this is the Tech and Power plain text benchmark. And as you can see, this is basically ASP.NET Core Linux. That's pretty raw. It's slower with basically when you put the NVC routing in. But it's right up there. This is the top, basically, of the list. And you can see just behind some of the very fast ones like Netty. And it's way ahead of things like Fulcrum, which is a really fast Python server. Many of you may have seen a lot of interest recently in the C# language in things like span and refs, etc., that kind of thing. A lot of the motivation, as far as I can tell, for that is around reducing the allocations and enabling you to work with effectively memory in such a way that essentially they can push the performance of Kestrel up to the same levels as Netty. Okay, that's really your gold standard, because Netty is what drives a lot of Java microservices, for example, because it's very, very fast. Okay, but as we said, the problem is it's not a fully featured web server, so you've got to stick it behind something, which is where IIS comes in if you're on Windows, or Nginx, or Apache if you're in the Unix world. I don't really know much about Apache, so I'm just going to talk about Nginx today. Okay. So Nginx is a cross-platform web server. It comes on Windows as well, if you're interested, and it serves content in response to HTTP or HTTPS. It also has some mail features. I don't really know where anyone that actually uses those, but it will support doing mail for you. So as a web server, standalone out of the box, it can serve static content. So if you have static HTML files, you can effectively use Nginx based as a web server to serve those up for you, right? But it can also call your application, right? So it can do that by doing proxy pass. So it just takes the HTTP that comes into it and it basically forwards that HTTP onto your application. It can also do things that we call fast CGI. So if your application supports fast CGI, it can pass to you over fast CGI. And that's quite common in the Python world. A lot of Python, basically, there's a Python standard called UWSGI. And people basically passed it over at, say, a TCP level, basically, to the other server. Generally speaking, what you're doing with Nginx is essentially you're always doing, it's always effectively doing I/O, right? So it's not an application container in the way that IIS is. It doesn't host your code anyway. What it does essentially, it says, is I receive an I/O as a web server and I know how to service that. I'll either read a file off disk and serve it to you, or I will call another I/O endpoint, be that your application essentially or something else, and get content out of that. So it treats essentially reading the content of your application pretty much like reading something from disk, just an I/O operation it's performing. Okay. As a result, it can be very fast by optimizing around basically the fact that it's only delivering I/O. Okay. When we talk about things like Nginx, one of the things to understand a little bit, I think is helpful, is a comparison between the world, say, of IIS and the world of Nginx. So typically what used to happen to us when we were using IIS on Windows was we get a request in from the user to an HTTP sys, and basically we get Windows Activation Service basically spins up and says, I'm going to look in the application host.config, and I'm going to find an application to deal with this request. And then essentially what it does is it looks at the detail in there, and it says, I'm going to spin up basically an app pool, and I spin up a worker process to service that app pool, and I'm going to handle your request. And under IIS 7 or later, with the integrated pipeline, everything goes through ASP.NET, including static files on disk. Okay. And it's essentially important to think about IIS less as a web server than as an application container, right? It hosts your application. This is the word of Docker, right? In Docker, what we have is a Docker host, which runs a Docker daemon, and what we do is then say, okay, I'm going to go and basically define some containers. I'm going to pull an image out of a registry somewhere. I'm going to basically build that container. I'm going to create a network so they can all talk to each other and have some data volumes they can all share. Okay, and that model is increasingly a lot how people are deploying. Be it Docker directly, be it Kubernetes running basically on AWS. That's becoming an increasingly common model. And the problem is, IIS doesn't make sense in that scenario. And there are two reasons for that. One is, essentially quite often, unless I'm going to run something like Nano, I don't want to run containers that basically are Windows because they are huge. I want something small, and I want something that's essentially a sandbox wrap around a process, which is what containers are. And second, this is a container model. There is no point in me running a container model inside a container model, right? Putting IIS on my container does not make any sense because I'm putting a container model inside a container, right? So as soon as I get here, I want something else. I want something effectively that's going to deal with that issue basically of serving the web for me without bringing in the need to be an application container on top. So the advantage of Nginx is I separate these concerns. I'm not being an application container and a web server. I'm just being a web server. All right, quick discussion of basically how web servers work nowadays. So you might think, and it's not an unreasonable assertion, that the way the web server would work is I receive a request from a web browser, says, here's I want to connect to you, I accept the connection, and then I use a thread to say, okay, hey connection, give me your data. I will then use that thread to go and process your request by creating some kind of HTTP handler, and I will respond to the request with you. Okay. The problem is that's pretty naive and wouldn't actually scale. What happens is when you receive a certain number of connections, you can spend all your time switching between threads and context switching. because you're going to run out basically of capacity on your server. You've only got so many cores. Once you see the number of cores, you're going to start doing context switching, and eventually your web server will spend more time context switching than it does actually serving requests. And eventually you'll run out of memory as well, because each thread will take a certain amount of memory, and eventually you'll start queuing requests, and your server then will start spitting out 500 errors because it can't take any more load. Okay, so we don't build web servers that way. We actually a bit more complicated. So this is the way that a modern web server works. I accept the connection coming in, and what I do is I actually say, right, well, I'm going to wait on effectively the operating system telling me effectively it's buffered all basically the bytes that I need to read. So I basically put something called a completion dispatcher, which says, hey, I'm going to wait on you being done, and when you're done, signal to me, and I will then process the work. Okay, and you have a kind of single thread here if you're something like libuv, but you can have effectively multiple threads if you have a slightly different model. So Kestrel is effectively using multiple threads, multiple libuv loops. You get multiple work processes in Nginx, we'll see that in a second. So effectively when something completes, I spin up a thread and then I say go away effectively and handle that. Now down here you can see as I talk to my HTTP handler, I may find there are points where I'm doing I/O in that process. I'm reading from disk, I'm talking to the database. And what I can do there is essentially the same thing. I can say effectively, right, well, I'll hand control back, and essentially I'll wait until you're completed, and I'll use this thread to go and service another request. And what that means is an individual thread can then service multiple requests, right? Talk about that, the libuv model effectively in Node.JS. But all web servers nowadays tend to work this way, right? So you're constantly handing off control when you're doing I/O, so you have a smaller number of threads. So what we can do then is see kind of how Nginx is built. This is Nginx Diagram. So Nginx has a master process. It's a supervisor worker pattern. The master process spins up and says, I'm now running Nginx. And what it does is spin up a number of worker processes. And those worker processes are things that actually handle requests for you. And it uses a kind of model of saying, right, well, I'm going to listen basically on a completion port. When things are ready to be dealt with, the thread will deal with them, and it will deal with them until they do some I/O again, and then I get queued on the completion port, and then effectively I'll service them when they're ready again, right? So a small number of threads can service a high number of requests, because in theory, most web applications tend to be I/O bound rather than CPU bound. Okay, that makes sense. The stuff over here, basically, I may talk to a proxy cache, so effectively Nginx comes to support basically for doing proxying, and we'll show you all that later. Okay. You can mention fast CGI and HTTP, so essentially if I'm not doing I/O or serving from the cache, I can go and get it basically from your web server. I can also talk by fast CGI to something, but also there's support for plugins to talk directly to things like Redis and Memcache. So rather than necessarily having to talk to your app to do that, I can actually say, I'll go and get the results basically for this, they live in Redis, so I can use those as distributed caches. I won't show you that today, but it's worth thinking about if you basically use those technologies. Okay. The heart of Nginx is essentially a configuration file. And we saw that earlier, I showed you the Nginx Conf, right? So you need to learn how to write one of those. That's really all you need to understand in order to use Nginx in your environment. And then essentially, its configure file is made up of a series of directives. So you've got a syntax for standard syntax on Unix for a comment. And then essentially we have a setting and a value and a semicolon. And we just set a whole lot of directives. And Nginx is modular. So we won't show you how to do it today, but you can effectively build Nginx from source, and you can change the modules that you have in your Nginx deployment. And Nginx lets you, each module that you bring in essentially brings in a new set of directives that you can use to manage Nginx. So, and then directives can be grouped as a block structure, so you can group directives. So I'll come back and explain what all these groups are, but you can see we've got basically an HTTP block, a server block, and a listen block. Within those blocks, we are setting directive values. Okay, so your config file effectively looks just like that. Okay, so the three modules that you essentially always get when you build an Nginx are effectively core. That basically says, where's my master process, how many workers have I got, how am I listening for things. Events, that says basically, I want to listen for events on completion ports, how am I doing that? You can control the actual technology used, it varies between the operating system, which one is best. There's a default one called poll, but you may want to use epoll or key depending on your operating system. And configuration, I won't show you much today, but just so you know it exists. Effectively, when you get a big config file, I'll show you some big config files because it's easy to have one file to show you guys. You can take a section of that, put another config file and just include it. So you can essentially break up your config file and make it easier to read. There are a few key modules we want to think about using, and I should try to explain to you today, that are really key to using as a web server. So there's HTTP core, and that lets us basically configure what's called virtual hosts. So a virtual host is really just your downstream that we're talking to. Rewrite, that lets you do URL rewriting. Upstream, so basically that's used to do load balancing. That's saying actually service this request with a pool of servers. Proxy module, which basically doesn't necessarily do load balancing at all, but lets us act as basically like a slide, but lets you act effectively as a reverse proxy. So lets you do things like caching, etc. for your site. Okay. You can build it from source if you want new options. There's pretty good instructions out there. Essentially, it's all about using configure to say what modules I want. That generates a makefile. You then build the makefile. Right? There's instructions out there if you need to do that. Generally, if you want to harden it or you want to basically add additional modules that don't come in, say, the apt-get or Docker default set, you'll want to do that. We don't do that today. Okay. And that modular system means it's very extensible. So third parties create modules that you can then plug into Nginx to do additional things. There's a project called OpenResty. So OpenResty basically brings in a Lua module into Nginx, and that lets you convert Nginx into an application server because you can then write Lua code that runs in response to HTTP requests. And on top of that, people have built something called Kong. So Kong is an API gateway built on top of Nginx that uses essentially modules in Nginx and Lua to effectively help you do things at the perimeter. For example, rate limiting, authorization, and other perimeter concerns. Okay, people heard of Kong or OpenResty? Okay.
Sorry, is this Kong another module that you add to, or is something on top of?
OpenResty is a module that you build into Nginx that lets you do Lua. Kong is essentially a set of modules that basically let you use OpenResty to effectively produce an API gateway. So effectively, it's all Nginx as its engine at the bottom, but effectively it's just a set of modules which have been built by that project to let you use it in that particular role. Make sense? Okay. So every Nginx config file has a kind of like the root, if you like, something that's basically not within another block. And generally at the root of the file, you're defining how Nginx is going to run. So you're saying I've got I've got a number of worker processes. Right, so I'm just saying for you can choose auto. Generally, you want the number of cores that you have. If you say auto, it will figure it out for you. And how I'm going to listen. So here I'm saying I'm running on Unix, so I'm going to use epoll. For those that can't see it at the bottom, it just says use epoll on worker connections 2048. I'm limiting the number of connections essentially that I will run basically on one given Nginx instance to 2048. Okay. The next stage is probably the most important one to understand is the HTTP block. The HTTP block says, I want to listen for HTTP requests. It's obviously the pretty fundamental thing we want to do with our web server, right? Within that HTTP block, we define a number of virtual server blocks. And the virtual server blocks essentially will tell us how to respond to requests. So a virtual server block is basically a listen directive, listen on this port, and a server name on this particular, addressed to this host. Okay, so I get a request in, it's addressed to a host and a port on that host, and I listen to those requests. Okay, and within that server block, I then may have another number of location blocks. So the location block says after that portion of the URI, there may be additional parts of the URI, and I can use those to route essentially the incoming HTTP request to a given provider. So it may be I just serve that as a static file, I'm serving straight off disk, but I may be passing that essentially via an HTTP proxy to your application or fast CGI to an application to actually deal with instead. Okay. Locations can be internal or external. So external just means this is a URI coming into the Nginx from basically the outside. And the internal means I've actually done some rewriting internally in Nginx and now created basically a mapping to an internal location which tells you how to handle it. You'll see an example of that in just a second. Okay. So this is a typical HTTP block. You can see that I'm saying effectively that I'm going to I've got some things here which say I want to optimize how TCP works. The TCP is a protocol. It's designed for things other than HTTP. And so in this case, we're just saying, actually, we want to really basically modify the way we're listening to make sure that we're listening in a way that's effective for HTTP, not for SMTP, etc. Okay. And then I'm saying effectively here, I want to listen on port 80. I'm on localhost because there's nothing else to find. Oh, actually, I'm on www.example.com, so I'm listening on www.example.com.80. And this is saying I'm at the root location. And at the root location, I'm going to use this thing called try files, which is actually a rewrite directive. And it says, try things in this order. First of all, just try serving that address off the disk. It's a static file. Or try serving off the disk basically with a slash after it's a static file, but it's actually a bit further down. Right? Or send them to this thing called Kestrel. And Kestrel is just another location I've defined. In that location, essentially, I'm saying proxy to pass this through to basically app 5000, right? Which basically is my Kestrel hosted ASP.NET Core app, right? The request comes in on port 80 for www.example.com. I look and see if I can serve it off disk. You can use a maintenance page here as well, right? So it's quite a common thing is to put /maintenance.html. If that exists, you go to the maintenance page. If not, it doesn't exist, you keep going down the line, right? So you can easily put up a maintenance page to say I'm under maintenance before you get to here. I think I'll show you that later on. And then essentially, I'm passing out to the proxy. All right. Let's have a look at reverse proxy. Shut that down before I get confused. Reverse proxy. Okay, good one. Let's fix that problem. Well, I've altered something. We can easily fix that. Right. What have I got? What are you thinking you're going to overwrite? Could be out directory somewhere. Let's just kill that for a second. Okay. So what I'll do is try that. Let's actually do the one with caching in it. I might as well. Right, it's happy again. While we talk about that, let's just build this over here. Oh, I've got this one open, that's why. So just complaining, I think, because I had that open, it had a lock, and it wasn't killing it for me, so I'm just going to rebuild this server. So while it's just shutting down. So here we have basically the Docker Compose file again. We've got a reverse proxy here. You can see we're basically saying to Nginx, basically expose 8080 and doing expose. We mentioned that kind of earlier. And we're saying, I'm going to push through here. And that's not right, actually. Where's my... And the Nginx config file, I've got a lot more in. Okay. So we talked about this earlier. What I'm doing here essentially is saying I want to optimize how Centerfile works in Unix. I want to optimize some of the TCP for HTTP. This is saying I want to limit the number of requests that I am receiving from any one IP address in a window of time. And I'm limiting some stuff about how much space you can use to store that history of requests. And I can also basically allow for given bursts of activity, right? That's just an example of the kind of thing you can get out of a proxy like this. I'm doing compression for all those given types. I'm turning server tokens off so you can't see the version. It's really hard to stop Nginx reporting that it is Nginx, but the best thing you can do is turn the version off so people can't exploit given version-based exploits. I'm doing some basic security stuff in terms of the headers. I'm adjusting some of the defaults around the keep alives and the collections. And I'm defining basically here a proxy. And I'll come back and talk about proxies in a second, just to stop me having to basically switch things. But the key thing to understand down here is I say, right, listen basically on port 80 for all requests, in other words, ones at the root location. So there's an order to which we match locations. It's worth reading up on Nginx. I'm not going to try and run through that with you today, but there's an order in which location blocks are matched, given that they effectively could overlap. And there are given directives. You can, in location blocks, you can use things like regular expressions. You can use things like equals to say exactly match this. And you'll want to go away and have a look at the documentation on Nginx around that to understand both what your options are in terms of matching and how it figures out when there are conflicts, which one to choose. Okay. Then it says try files line, which basically says have a look and see if there's a maintenance HTML. If so, serve that. If not, see if you can basically serve this request by looking up a location on disk. If you can't, pass it through basically to this location, Kestrel. That's an internal basically location. The internal location, Kestrel, just says, okay, pass it through basically to Greetings Web 5000. So I'm just effectively using the internal DNS basically on the Docker host to look up greetings.web and find basically that port 5000. And I'm setting a few headers essentially on the proxy port. Okay. Let me just build this in the background while we're talking. Okay. What we'll do is we'll just talk a little bit about some of these cache headers. We'll come back to talk them while I'm building that. We'll talk about caching in a second. You can see here we're defining something called proxy cache path. So we're saying essentially cache some stuff and put it here. So Nginx by default will cache on disk for you, right? But you can do stuff to basically offload caching and stuff to basically to things like Redis or Memcached. And here we're saying set a number of headers up, how long the cache should be valid. Proxy, these settings, proxy revalidate on means you should always essentially check with the origin server if I turn that on with saying if modified since header or if none match header, depending whether you're using kind of last modified or e tags to determine whether the content is stale. Minimum uses down here says only cache after a certain number of hits. Use stale error says in the event that the origin server returns you basically one of these errors like a 500, just serve results out of the cache. Very, very useful. Background update says when I get a request in and the cache is kind of basically invalid, then serve the stale result, then go to the origin server and refresh. So this first person gets the stale result, subsequent requests get refreshed in the background. And lock-on says, if I receive a whole burst of traffic asking for the same page, which is cacheable, then what I want you to do is to let the first person go to the origin server, first request, bring back basically the cached result, serve it out basically, and then everybody else then hits the cache and serves the cached result. That stops you otherwise continually revalidating your the cache and saying everyone now in a whole burst says, I'm going to get it, replace the one in the cache, I'm going to get it, replace the one in the cache. That doesn't work. So what you want to do is use the lock-on. Okay, right. Let me do this, Docker Compose. So we're going to bring up Docker Compose at this point. Okay. So the most basic use of this we kind of showed you earlier, which is around the idea effectively of saying, well, I want to basically hit 8080 rather than 5000 because that's no longer exposed. We'll just remind you of that. And then we'll talk a little bit about caching. So this essentially is going away effectively and hitting our endpoint that gets us multiple greetings. Can you see there? It's the sunlight killing you guys. Thanks, mate. Okay. So you can see here I've got a header back, and the header basically got a lot more information in it now. It's talking about basically things like cache control, various protections that we identified, and we're serving everything back. But you can see we're hitting on 8080. Okay. So I'm going to drop away from that slide for a second. How comfortable are you all about HTTP caching? Who thinks they know a lot about it? Who thinks they don't know much about it? Comfortable? Okay, and we'll do some slides on this then. Okay, hang on. Let's play from current slide. Come on. And then we'll show you how the reverse caching stuff works. Okay. Okay. Right, so Nginx is often described as a reverse proxy. What does that mean? That means it sits in front of your server as opposed to a forward proxy that sits essentially, say, in the enterprise and sits between clients in the enterprise and the outside world, right? In most cases, effectively, it disguises effectively where those requests originally came from, but also is mainly used for things like caching. So your forward proxy server lets your administrator cache the BBC's website so that essentially you're not continually using bandwidth when everyone at lunchtime decides to have a look at the news, right? The reverse proxy server lets you cache basically responses from your application so that you're not constantly hitting the origin server and you can then effectively scale more easily. Right. The thing to understand about HTTP caching is essentially the way it really works is you cache downstream of your application server. In a lot of cases, you'll see things like ASP.NET Core having middleware that talks about doing caching in the middleware, right? And it's useful essentially in your application to cache things like I don't want to walk to the database, etc. But the way that the web scales is to cache basically using proxies or your browser. You cache downstream from the origin server. And what we're doing is we're trading performance for the risk of becoming stale, right? So we say I'm going to get a faster response. If it's in your forward proxy server or my browser, it's much closer to me and the latency is lower, right? If it's in my provider's basically site, it's essentially preventing me having to go to the database, etc. effectively, so the latency is still lower. Okay. We're trading availability for consistency. In some cases, essentially, we may find that basically we have more availability through using a cache. In other words, we can get some results even in the event of an error, but we may be inconsistent, maybe serving stale results. The browser cache is very low latency because it's where I am. So anything basically that's cached in my browser makes me look very responsive, but it's not shared, so everybody has a copy. Okay. And a proxy cache is shared because essentially everyone that goes to that proxy can effectively use the cached version. Right? So typical kind of thing we use to do caching, max age. So what we're saying here is when we make a browser request, we use a cache control header with a max age of 30, and we say, essentially, when we get the response initially, we say max age of 30 on the get response, right? And so what we're saying is, this now lives for basically 30 seconds. When you request it from the browser in future, you can skip going to the origin server, provided it was in 30 seconds the last window that you got that. Right. So the first request says, put in the browser for 30 seconds, this essentially response, and then the next 30 seconds, if you do another GET request, just serve within the browser. At a certain point, then it expires, and what then happens, it doesn't necessarily have to go all the way to the origin server and get a new version. It can ask the origin server via basically if modified since or if none match, if it's still valid, and continue to extend that time slice and serve it. Expires is very similar to max age. Rather than giving you a window, it just says there's a specific point in time when it's going to actually expire. Last modified, so what happens is this, effectively, when you get a response from the server, it says, this is the last modified date. In other words, this is basically when it was created. And you can then essentially pass across a if modified since from the browser that says, this is the version I have, it's actually on this date, do you have a later version? And if the proxy doesn't, the proxy server can say there's no later version, basically, right? So effectively, you have the correct version. You can also force revalidation. So you can tell the proxy server, you need to ask the origin server if the version you've got is still current. And what happens is you can say with the last modified date across the modified since right to the origin server, if you support it in your code base, hey, is this still valid? And you can return a 304, which basically says it's not modified to the proxy cache, is to say you can serve this version back out to customers, right? And this is the way the web scales, and it's the way that the web copes with temporal coupling. Temporal coupling is the notion that it needs to be up in order to basically serve requests. But actually, if I can hit a proxy, I can offload that. Right. We can always use the cache control header for privacy. So public means all proxies can store it. Private means only the browser can store it. It's sensitive information, right? I don't want everyone to store it in between. No store means nobody keeps a copy, right? Please don't keep it. It's too sensitive. Even in the browser, because someone may get onto that machine and basically look in the cache. No cache. No cache is not what people think. No cache is not intended to be no one gets a copy. No cache is intended to be that you must revalidate the copy you have with the origin server via if modified since or if none match. Unfortunately, no cache has been badly implemented by developers, and so no cache has actually come in most cases to mean the same thing as no store. So most proxies and browsers now don't keep a copy if you say no cache. So if you want the behavior that no cache used to have, you have to start using things like must revalidate instead, right? We as developers all got that wrong. And this is a typical, basically, proxy cache statement. So I'm saying at the top, basically in Nginx, define my proxy cache, and then I'm saying further down, essentially, what I want you to do is proxy cache to my cache, and I've turned on various settings. So I want you to revalidate with the server, minimum number of uses, serve stale pages for errors, update your cache in the background, and only the first person in a whole burst of traffic goes to the origin server to fill the cache. Okay. Let me show you caching. So this version essentially has caching in it. So if I do this, what I can see when I do that particular response is a whole load of IDs for these particular greetings. So if I grab that and go to here, so this is request a specific ID, and I'm all fingers and thumbs. That isn't really what I wanted, is it? Driving a lectern with a trackpad is not the best skill in the world that I own. Come on. In a minute, I'll invite one of you up to drive for me. Okay, great. So, oops. What have I done? Say again, sorry? Yeah, hang on. Just scrolling towards the end. Oh, yep. Thank you very much. Okay. So I can send a request for that greeting to the back end and say, give me that one specifically. I can. There we go. So basically what's happened is this has gone over to the browser. Can you see there's a header there, which basically I've asked the proxy cache to give us and say, did you serve this from the cache or not? And first time around, obviously, it's saying miss. It's saying that wasn't in the cache. I went to the origin server to get it. You can also see over here in the output basically from Docker that effectively I've gone to the origin server. Okay, next time around, when I request it, because I've asked it to cache, and I'll show you how we do that in a second, it's going to change that status to hit. So this time around, it's served that directly out of the cache rather than going to my application server. And you can see, probably those of you that, it's right at the bottom of the line, unfortunately, but you can see it's just calling basically straight to the proxy. Those of you who can actually see that line at the bottom from Docker. All you have to do to really enable that is on your controller within, let's just shut that down, that'll open in a better way for you all. Right, so you can see here that effectively there is a response cache attribute basically placed on that get. This one says never because it's to get all of them, so that will keep updating and I'm not doing any kind of cache invalidation. And this one on get greeting says basically what I want you to do is cache with a given profile. We set up the profiles in this file. And you can see effectively, it's basically built into Web API. You can see I'm setting up basically one that says hold this basically for 60 seconds and one that's essentially saying don't hold it at all. And with that on, essentially I will return the correct cache control headers when I'm called, which are picked up by Nginx, which then essentially will basically serve those results from the cache as we just saw. Okay, make sense? Okay, let's go back to the slides. We're doing for time, great, okay. Let me show you load balancing. Okay, so the other thing which we kind of alluded to at the beginning was what I may want to do essentially is behind my proxy, not just have the one application server, the one instance of my application. What I may want to do is have multiple instances of my application. Okay. And so that's where effectively we come to this upstream directive. So we define basically this block called upstream, and in upstream we basically put either the IP address listing them one by one of every application server that we have, or essentially we're using something that can be picked up by basically a domain name service to say, okay, go away and find me basically that particular app server, and I will then push requests to that collection of app servers. And you can generally, it defaults to round robin, but you can use you can set a variety of ways in which Nginx will basically talk to that pool. So you can say things like basically least connection, etc. Okay. I won't show you today, but you can basically use health checks there as well to determine which servers basically are viable to load balance across to. Okay. Let me just stop this one so that I can move across. Double save. Okay, and I'm going to move to Nginx. I use this one, I think, so I can show you that. Okay, so in this Nginx conf file, you're going to find essentially that I need to rebuild. Actually, let me just do that. I've got a little trick here. So the resolver here and the set upstream. So resolver is basically saying to Nginx, where should you go to find the names? You don't have to do this all the time, but this is a trick for Docker. And this essentially address refers to basically Docker's internal domain name server that is built basically to use with that network. And what this means is as you add new containers in, because I've got a variable that gets evaluated at runtime set upstream here, it will always go to the resolver and say, well, what servers do you have available in order to resolve that request? Okay. Otherwise, you may find things like Docker. It works on Docker for Windows and Docker for Mac. When you add a new container, it automatically knows you don't need to do this. But on things like Docker Toolbox, you have to do this because it doesn't pick up the fact that you've added a new container. Otherwise, alternatively, you can just use an upstream group to do this, as you saw in the slide deck. Okay. Now, what I'm going to do is do Docker Compose up, but I'm going to add a scale parameter. So I'm going to tell Docker Compose I want 3 instances of my web app. Hang on a sec. I will clear this screen so you guys can see that at the back. So I'm saying bring up 3 instances of my web server. When I've built that, what I'm going to do is then run the same scenario I've been running all along, basically via HTTP. But what we're going to do is see which web servers handle those requests. While we're just seeing that, because we're running close towards the end of time, I'll just talk about a couple of things I haven't shown you. You can do URL writing. I haven't had time to show you that today. Essentially, it's all regular expression based, and essentially you can say, I'm going to take this location when I get the result into to this match, send it to basically this address instead, right? So you saw we had external blocks and internal blocks on location. So if I match location essentially with the external block, I can then say, well, they're sent to this internal address. In other words, effectively rewriting that URL to be posted elsewhere. Okay, so I can use regular expressions to pick out parts of that given URI and repass them through to another URI. Health checks we haven't talked about. Monitoring is the other thing. You can do a lot to actually monitor. The debug logs are pretty comprehensive, and when you turn them on, they're very handy, particularly if you're doing things like URL rewriting and you want to understand why isn't it working. It will tell you basically what process it's using to try and match the URL that you've generated against stuff. Okay. This is inordinately slow for some reason I don't understand, which is worrying. Why are you being so slow at this moment in time? All right, let me just show you a couple of slides while that filters through. I don't think we'll have time to do SSL. SSL is straightforward. You just basically need to generate a certificate and you need to tell basically Nginx where that certificate lives, and it will do SSL for you. Right, it's very straightforward. You just add into reverse proxy. I do not know why this is taking so long to bring up 3 web servers. It never takes this long, he said. The demo gods have decided to hate me. Whoop, there we go. Okay, great. So you can see I've got some color coding there, and I've got basically at least 2 web servers that seem to have appeared. I don't know what happened to web server number 3. Let's figure that out later. When I send this request, what you'll see is essentially that was served by web 2. And then if we do it again a few times, hopefully what we'll see is that eventually we'll set it enough times to see different, so you can see in the color coding, different web servers are now responding to that request. So we've essentially load balanced across that collection of web servers that we set up. All right. What I'll also just show you is, if you're not on Docker Toolbox, the simpler syntax for this is just to use this upstream group, right? So it figures out that basically web is saying look in the DNS for something called web. So there'll be a greetings web 1, a greetings web, that's how basically Docker creates them, and it will find one of those round robin to basically on port 5000. Okay. All right. I have 2 slides more to show you. I am probably slightly over time, apologies. Right. So find me. I've got some other. There's some bits of demos. Like if you're desperate to see it, come and find me, and we'll sit down at a table together, and I'll show you things like I've got an SSL demo and a URL rewriting demo. You can see. So if that's really important to you, just find me during the day, and we'll sit down at a table together, and I'll show it to you. Or questions, or things we didn't show you today. We didn't show you how to build from source. That's something you're probably going to want to do when you want to harden the Nginx you're using for your production servers. We didn't show you health checks, which are useful essentially with things like load balancing. You effectively define a health check endpoint or a page essentially for your app server and say, talk to this to determine whether or not effectively that web server is viable before you route to it. We showed you, we didn't really talk about includes, but to break up that configuration file, take a whole section, like for example the gzip compression section, put it in a gzip.conf, then just do include gzip.conf in your master. It helps clean your files up, make them easier to read, and it lets you reuse standard configuration elements in your organization. We didn't show you passing through requests to Redis and Memcached, but you can do that. You can essentially say, serve this thing out of Redis and Memcached, right? And we didn't show you how to do monitoring. It comes with a lot of options for monitoring. There's also basically a commercial thing called Nginx Plus, which is the Nginx Incorporated do, and they have a whole range of commercial tools built on top of Nginx for things, help with like monitoring and also using this in a microservices environment as a proxy for a microservice, which is Nginx Unit, I think. All right, thank you. Don't forget to vote on the way out. Feedback is very helpful. Thank you for coming, and I appreciate that you came to see me and not Scott building Kubernetes on Raspberry Pi. I thought it might have nobody. Hopefully that gave you some idea of what Nginx does, how you use it, and why you might want to. There's a bit of a learning curve to it. Start simple, right? Just start doing by saying, here's my website. What I want to do is stick a proxy just to pass straight through to it in front, and then build up more and more over time. That's the way I would do it, because you will find things go wrong, and investigate how you basically, which you saw the line once, but you probably don't remember, how you put in an error log with debug on it, and you can start a debug version. Docker comes with a pre-built Nginx debug you can use, which will let you essentially build debug output, and that helps you trace things like URL rewriting and get your configuration file right. Apt-Get doesn't come with an Nginx debug. If you want Nginx debug deployed actually to a non-Docker environment, you're going to have to build it yourself, unfortunately. Okay, thanks very much.